We will now discuss the solution of a problem from the section Linear Algebra that appeared in a NET National Eligibility Test. The question is on non-homogeneous system of linear equations. That question has appeared in CSIR-UGC National Eligibility Test conducted on 26th November 2020 in the afternoon shift. The problem is from the section C and it carries 4.75 marks. The problem is, let A be an n by n real matrix. Let B be an n by 1 vector. Suppose Ax is equal to B has no solution. Which of the following statements are true? 1. There exists an n by 1 vector C such that Ax is equal to C has a unique solution. That is the option 1. Option 2. There exists infinitely many vectors C such that Ax is equal to C has no solution. Option 3. If Y is the first column of the matrix A, then Ax is equal to Y has a unique solution. Option 4. Determinant of A is equal to 0. We will now discuss the solution. We have a real square matrix capital A of order n, and we also have B is an n by 1 vector. Given Ax is equal to B has no solution, meaning that the system of non-homogeneous linear equations Ax is equal to B is inconsistent. It means that the rank of the coefficient matrix A is not equal to the rank of the augmented matrix A with the last column B, and that is less than or equal to n. This implies rank of A less than n strictly. That implies determinant of A is equal to 0. So our option 4 says determinant of A is equal to 0. Therefore, the option 4 is true. Now we will now check the truth of the option 1. There exists an n by 1 vector C such that Ax is equal to C has a unique solution. Suppose that there exists an n by 1 vector C such that Ax is equal to C has a unique solution. It means what? Because it has a unique solution, it is consistent and it has only one solution. This implies rank of A is equal to rank of the augmented matrix A with C is equal to n, where n is the number of columns or the number of variables. This means rank of A is equal to n. That means determinant of A is not equal to 0. So the rank of A is n, but we have the rank of A less than n, which is a contradiction. Therefore, the option 1 is not true. Let us get into the option 2. The option 2 says there exists infinitely many vectors C such that Ax is equal to C has no solution. We have the system of equations Ax is equal to B is inconsistent, meaning the rank of A not equal to the rank of the augmented matrix A with B. Then the row echelon form of the augmented matrix A with B is this. So the row echelon form, this is the row echelon form, and because it is inconsistent, we will have 0 0, the last row as 0 0 0 bn prime, where bn prime not equal to 0. because it is inconsistent. It is inconsistent. Now, what we do is we consider the system of equations Ax is equal to Kb, where K is any non-zero real constant, real number. So K times B, B is the column vector, K times B. So the vector will be Kb1, Kb2, Kb3, Kbn. So that will be the. So now what we do is we perform the same row operations what we have done in this case to reduce AB to this echelon form. The same sequence of row operations we also perform Ax is equal to Kb. Then we will get a norm, we will get the row echelon form of Ax is equal to Kb, that is the row echelon form of the augmented matrix A with Kb. So performing the same sequence of row operations that reduced the augmented matrix A with B to this above row echelon form, those same operations we will perform on the augmented matrix A with KB. Then we obtain the row echelon form of the augmented matrix A with KB as the above only, the above as above only, but the last column will be multiplied by k. So we will get echelon form like this, and the last row will be 0 0 0 k b n prime. K not equal to 0 because k is a non-zero real number, and bn prime is not equal to 0. K into bn prime is not equal to 0. This shows the rank of A is not equal to the rank of the augmented matrix A with KB. And so Ax is equal to Kb, the system of non-homogeneous equations, has no solution for all k belongs to R, k not equal to 0. So thus there exists infinitely many vectors C is equal to Kb. K is a real number, any real number, k not equal to 0. So thus there exists infinitely many vectors C such that Ax is equal to C has no solution. Therefore, the option 2 is true. This is true. There exists infinitely many vectors C such that Ax is equal to C has no solution. So that is the option 2 which is true. We continue. Option 3. If y is the first column of A, then Ax is equal to y has a unique solution. So we have the y is the first column of A. Y is the first column of A. And consider Ax is equal to y, the system of non-homogeneous linear equations. Ax is equal to y. Then the row echelon form of the augmented matrix A with y will be this. And note that this first column is 1 0 0, will be same as the last column. Why? Because y is the first column of A and Ax is equal to y, and in the augmented matrix the last column is also y. And when y is reduced to row echelon form, that becomes 1 0 0 0 0, and so also this also because the same row operations you also perform on this. So therefore you get 1 0 0 0 here also. Now what you see is the rank of A, the rank of A is equal to the rank of the augmented matrix, rank of the augmented matrix A with y. So it is consistent. Ax is equal to y, the system is consistent and has infinitely many solutions. Why? Because the rank of A is less than n, and it is consistent and has infinitely many solutions. Our option 3 says it has a unique solution. Therefore our option 3 is not true. So therefore the option 3 is not true. So now let us see what is the situation now. So the options 1 and 3 we have already seen they are not true. 2 and 4 are true. So 2 and 4 are true. So our final answer is the option 2 and 4 are true. So that is the discussion of the solution of a problem from linear algebra, which is based on the results of non-homogeneous system of linear equations. Looks to be a good example, and I hope that you have understood the solution of it and liked the solution also. I wish you all the best. Thank you.